So I like to start I'm just going to dive right in, okay? So I like to start my talk because I do like interaction. So I like to start my talk actually with a question for all of you, okay? So be ready. This is audience participation, okay? So, but let me set this up. So the genesis of this question is, well, the question itself is, what's the probability of a 50% drawdown or drop in stocks over a 100-year period? Okay, and the genesis for this, or the reason for this question, is why it's so important, comes from this notion of the Black Swan, which is the idea that from Nassim Taleb, you've probably maybe heard of him, but he wrote a famous book called The Black Swan, and in that book he talks about, he defines a black swan as having three criteria. One is that a black swan is a very large event with very large consequences. And then two, the events are unforeseen, so we don't see them. And then the third element is that they're not predictable. And so the genesis of this question kind of comes from that, are such large negative events unexpected? Okay? And then Alan Greenspan famously said that the 2000 event, the global financial crisis, was a once-in-a-century event. Again, suggesting that that the financial crisis is very rare and unexpected. Okay, so what I want to do is pose this question to all of you. What is the probability, okay, I assume everyone's had at least some math, some statistics, so what's the probability of a 50% decline, cumulative decline in stocks during a 100-year period? And this, the authors of this study make two assumptions, very realistic assumptions. That they assume a 7.5% return in stocks each year with an 18% standard deviation. Okay, so this question is not something that I actually posed. It comes from a Financial Analyst Journal article. Financial Analyst Journal, by the way, is a journal that I happen to be editor of, so you'll see a number of citations to the FAJ as I go through my talk today. And this is one such example of the type of research that we publish in the FAJ. So these two authors actually posed this question and then, of course, answered it for the readers. And so what I'd like to do is pose this question to all of you. So, and I'm going to pose it very simply. So how many of you would agree with Alan Greenspan and Nassim Taleb that black swans are, in financial markets, are indeed to be unexpected? That is, they're very rare. There's a low probability event. So how many of you would say it's a low probability event? So no hands are going up. How many of you would say it's a medium probability event? A little more like a flip of a coin, say 50% chance that we would have such a drawdown. And so no hands are going up. And so how many of you would say, so therefore all of you must say, all hands must go up to say it's a high probability event. So it's a very high, it's a very, we would expect with a very high probability such an event to occur. So I must put all of you into that third camp. And so congratulations, because that is in fact the answer. So the answer, if you all can see this, am I saying okay? Is this okay? So the answer is 90%. So a 50% drawdown decline in stocks is almost a certainty to happen in any given 100-year period. Okay, so that result adds a lot of clarity, though no one here was surprised by that. When I was given this talk, about rare events and risk in financial markets before the financial crisis, almost the opposite answer I would get for my question. Okay, so this is, people sometimes learn the hard way, but it's very true that these are not such rare events. In fact, my friend Larry Siegel wrote an article in the Financial Analyst Journal in 2010. I don't know if you can see this or not, but all of these are in the Financial Analyst Journal, by the way. And if you all would like to see any of these articles or read them, just get in touch with me. I'm happy to make them available for you. So in any event, my friend Larry Siegel and I were having dinner one night, and he said, we were talking about this black swan, and he said, there really is no such thing as a black swan, which we both agreed to. And he said, what they are, they're black turkeys. And so he coined this black turkey phrase. But then he wrote this article that sort of made that argument. in part of making that argument, he listed about a dozen or so cases in the last 100 years or so globally where various financial markets declined by 50% or more. So again, just more evidence that these large drawdowns, these large negative returns are not so rare, and so therefore we should expect them. And so the consequence of this is that we need to create more robust portfolios that are adaptive and understand the risk, the true risk in nature in financial markets. So what that means in a very simple way is, we need more padding. Portfolios need more padding so that we have a better ability to anticipate outcomes for investors, okay? So that's one quick, simple takeaway from all of this in terms of how do you take this idea and apply it to practice. So in other words, we need to build portfolios that accommodate this. And I'm going to talk more about this as we go through my remarks this morning. So my thesis, so this kind of brings me all to the sort of the thesis today, which is that we financial economists have not done a particularly good job of understanding and explaining risk in financial markets, not only to the investment community but to the investing public, and that we need to do a better job. So that's part of my own personal mission and things that is very much on my mind that I spend time talking about and writing about. And so you'll see some research that I've contributed to this discussion as well as we go through my remarks. So when one thinks about risk in financial markets, you really should start with risk in the overall economy, because after all, financial market returns derive from the overall economy, by definition, right? Corporations make profits, and those profits are tied to the overall economy. We see that today, right, with the large downswing in the macroeconomy. We see corporate profits declining constantly. So I did this graph, a very simple graph that showed the year over year. So this is the change in the S&P 500. So in stocks, that's the blue line, versus the red line, which is the change in GDP. This goes back to the mid 1950s or mid 1940s. And so what you see from this is very obviously that the volatility of stock markets is much, much greater than the volatility of overall economy. And so that's one quick takeaway. The second quick takeaway is if you take your eye to the right of this green line, you'll see this red line. How does this red line relate, this side, the right of the red line, relate to the left of the red line? And I think you can see this very clearly, very quickly, that it's less volatile, right? It's more damped.
If I may ask a question, all the articles that you have shown us about the Black Swans were written on 2010.
Yes.
Were there articles before the financial crisis that were actually thinking that there could be like this kind of Black Swans?
Yes.
Or was it, we have heard of Rubini, but there were also
right.
all other concepts before the economic crisis.
Sure. The answer is yes, there were. In fact, you may have heard of Bob Shiller, Robert Shiller from Yale University. I published an article from him in around 2006, and I don't have that slide in my deck. I used to have that slide in my deck before the financial crisis, in fact, where I showed the Robert Shiller slide that showed housing prices relative to incomes, which is a very simple way of saying that if in capital markets, if the ability to pay for something gets disconnected from the price of that something, whatever that is, then it doesn't usually end very well, right? Because prices cannot be disconnected from the underlying. In that way, capital markets are like that, right? And so I published an article by Robert Shiller in 2006 that made the case of the next bubble. And so he was talking a lot about the last bubble, which was, of course, the internet bubble in 2000, but then he transitioned into the next bubble, which he felt would be the housing market. And so yes, he talked about that. In fact, I have an article that I may have cited up here that I wrote in about 2007. It was published in 2008, where I said something about, we have time to mitigate this risk before the downfall comes. And so a number of us were talking about this, but there's some behavioral reasons for why it wasn't widely dispersed, and I'm going to talk about that in just a minute. So there were people beyond Rubini who were concerned about this, people that were raising their hands. But I can tell you from my own experience, even when I was out giving talks and I was showing these slides from Schiller and also from Reinhardt and Rogoff, who were also talking about the housing bubble before the crisis. They were also talking about sovereign crisis before the crisis. So these are researchers that I follow. And so when I'm out talking, I try to raise up their research to encourage people to read it. But I can tell you from my own personal experience when I was sharing these, there's a lot of disbelief in the crowd. So I'm not so surprised by that for reasons that I'll explain a little bit later. But thank you for that. So this period to the right, which began around the mid-1980s, is well known. It's called the Great Moderation by financial economists. And there's a number of reasons for it. One is that the global economy, or that the economy has become more global. And we all know that diversification dampens swings. We do have better fiscal policy. We have better fiscal programs that provide things like unemployment insurance and Social Security and things of that sort, which dampens swings. We also have monetary policy, which has improved to the point of assisting swings to be more dampened. The counter, and those things are not all that controversial, they're very well understood. The more controversial aspect of this is that the monetary policy as pursued, at least in the US, and perhaps elsewhere, is that by dampening these swings in the macroeconomy, financial participants think that, well, my downside is protected, so I don't have as much downside as I did before. However, that thought process hasn't borne out because what you see is these swings, which are in stocks, is equal to the swings before. In fact, I've calculated the standard deviation of this period to this period in stocks, and it's about the same. It's about 18% per year. However, the swings in GDP are about half. So we've gone from about 4% volatility to about 2% volatility. And so roughly speaking, the ratio of volatility from the GDP to stocks is about doubled as a result. So this is a real concern. This is a real concern because we don't see it going away, right? I mean, this is something that seems to stay. So let's talk a little bit more about this. We financial economists, as I said, we haven't done a particularly good job of understanding and explaining risk in financial markets. In fact, there is a study, there's an article in the Financial Analyst Journal in 2001 where Mark Rubenstein said that when he was earning his PhD dissertation, that he was taught to use rational asset pricing always and forever, and only if everything else failed were you to resort to irrational behavior. And in fact, he called this the prime directive, and I sometimes call it, and others sometimes call it physics envy. So what that means is that we've attempted to build models of the macroeconomy that are perfect models, that assume perfect behavior and consistent behavior. And the reality is more like a shark than physics. So in other words, sharks, humans have free will to make decisions. So if I have a rock and I throw the rock across this room, that rock has no free will, right? We can predict its movement, we can predict its trajectory, etc., based on the laws of physics, and we can do that very, very accurately. However, if I have a bird in my hand and I release that bird into the air, we can really make no predictions as to where that bird is going to go. So because the bird has free will. And so humans are like that as well. And so models that presume perfect behavior, presume consistent behavior amongst humans are, in my view, deemed to fail, or are going to fail. They're not going to work very well. And so Stephen Ross said this in 2001. He said, finance is really a study of sharks, not of rational man. And Dick Thaler, in the FHA in 1999, it's kind of hard to see this, but in 1999, an FHA article said that behavioral finance is a redundant phrase, and then I love this, what other kind of finance is there? So, I think that this idea that markets aren't perfect has been around for a while, so this sort of answers your question that people have been saying this for a while. This was 1999, but the idea of behavioral finance really didn't catch on very quickly. People were very resistant to it. Now, of course, people are much more open to it. So all of this idea of behavioral finance has created an entire area of financial economics called the study of behavioral finance. And behavioral finance economists have gone about finding ways that we humans tend to make consistent mistakes in our judgment in the way that we think. And so these I call behavioral pitfalls, behavioral errors or behavioral pitfalls, because we all have them, and they tend to trip us up, lead us to make mistakes in our judgment and thinking. And so you probably studied some of these, if not all of them. These are some of the terms, the behavioral finance terms that have been identified by the literature. And so if you've not read about some of these, I would encourage you to do so. It's very, very fun reading, very fun to learn about ourselves. Take it with a sense of humor, as it's intended in many times, because they tend to be very true. So what I want to do is, I can't talk about all of these today, though they're all fun to talk about. I'm going to talk about a few of these as they relate to risk.
Because one of the appeal of the rational model is that it's more general than the behavioral, because the behavioral, there is all these aspects that are all very sort of, I was going to say limited, but sort of the confirmation bias, so it's
Right.
something.
Right.
And I guess that's also why financial economists like sort of the rational expectations
Mhm.
framework, because,
Yes.
and I wonder whether you can reconcile sort of this search for generality that in science people typically have.
Yeah.
And at the same time, these facts that are true, I mean, because
Right.
these behavioral facts are indeed something that is true in
Yes.
reality.
Yeah, I agree with everything you said. I mean, we are drawn to the rational models, and I'm not saying the rational models have no use or no value. They have very important value, but I think they're a starting point. And so to think that they're the end point is I think a mistake. So I don't mean to dismiss Sargent. He just won a Nobel Prize in economics. I studied Sargent, very strongly when I was in graduate school, and think and believe that they are also very powerful models. However, we need to understand their limitations, and the limitations of those models are all of these things. And so the idea of working, these things, into our models is not complete, and it never will be complete, because we cannot model these things perfectly, because humans, again, have free will. So it's going to be an ongoing challenge forever. And what I want to do is talk a little bit about what do you do about this. And I have some examples of what you do about this. But what I believe is that you don't have a model. In this case, I'm talking about risk in financial markets. You don't have a model of risk in financial markets. You have a dashboard. You have a series of models of risk in financial markets that help give you a sense and a gauge of the level of risk in financial markets and where we're headed. So I like to use the example of when I go to visit my doctor, the first thing that the nurse does is she does three things, right? She takes my pulse, she takes my blood pressure, and she takes my temperature. She doesn't do one thing, she does three things. She creates very quickly, very succinctly, a dashboard, right, for my health. If one of those three things is sort of out of the norm, then it begins the investigation, and so on, right? And so there's no quick answer. If my temperature is high, it doesn't say what is wrong with me. It just says there's something going on here we need to investigate. And I think when thinking about risk in financial markets, we need to create monitors that are similar to that, so that we can begin to think about what is going on here. And so essentially what I'm saying is we need to overlay our judgment and our opinion in the way that sociobiological researchers do that in their studies. It's a great question. So what I want to do is give some examples of how these play out at risk in financial markets. And the first I want to talk about is the overconfidence bias. Have any of you heard of the overconfidence bias? No. We're getting some heads nodding.
Yeah.
Okay. So the overconfidence bias, I give an example of this, which I take from the Wall Street Journal. It has really nothing to do about finance at all. But when I read the article, I thought it had everything to do with finance. So I'm going to share that with you. And so the article was written by an individual who did a survey of amateur male golfers. And I know in Spain you have some great golfers that I like to follow. I'm sure you do as well. And so they did a survey and they said, well, how far do you hit your golf ball off the tee? Right? So for those of you who know about golf, very simple game. You hit your ball off the tee as far as you can so you can get as close to the pin to score. Okay? And so the amateur male golfers, you can see where this is going. They said this is in yards. They hit their golf ball 222 yards off the tee. The reality is that they only hit their golf ball 192. So there's about a 15 or 20% gap in terms of what amateur male golfers think they can do versus what the reality of what they can do. This gap is further exacerbated by the following statistic that came from this article. The article went on to say that 50% of the respondents said that they hit their golf ball 250 yards or more consistently off the tee. And so when I say that, I can tell the golfers in the room because they laugh, but that's true. That's what they said. 50% said they hit it 250 yards or farther, and the reality is 2%. So 50% said that they did, 2% actually do. I believe the 2% number because I've tried that and it doesn't work so well for us. And so there's a huge gap between what we think we can do versus what we can actually do. And in golf, it's a fun story to tell if you're an amateur male golfer. The risks are pretty small. To this overconfidence bias, it means your golf ball is going to go for a swim, perhaps that's 190 yards out when you thought you could clear the water hazard, when in fact you couldn't. So the risk isn't so big. But in financial markets, this is a very big deal because overconfidence encourages excessive risk taking. Do you see how this can happen? Right? We build a portfolio, we make a purchase of a risky asset, be it stocks or be it housing or some other risky asset, and we think we have it under control, right? We think that we tend to convince ourselves that we understand the risk, that we have our arms around it, and that we can put that risk in a cage and lock it up. And in fact, we cannot. Because again, financial markets have free will, and I like to say financial markets can go anywhere and do anything. And so we have this overconfidence, and in fact, it's just not true. Another story I like to tell is that at the height of the financial crisis, there was an interview with the then CEO of Citigroup. You all may have heard this story, Chuck Prince, and he was asked about the financial crisis and the impact of the financial crisis on his business, and he said, "It's no big deal, we have our arms around it." That was the quote. People have probably heard that. I don't know if you've heard that here or not, but it's a pretty famous quote in the US because it was conveying the notion that we have this under control, right? And that was exuding overconfidence, and it's a perfect example. And so this overconfidence bias, it's embedded in us, right? It's not just Wall Street, it's not just people involved in capital markets, it's everywhere, it's part of us. It's just that in capital markets, it has really large consequences, or can have really large consequences, whereas in golf, maybe not such a big deal. Okay. And so I wrote this article in 2011. The article that I mentioned before that I wrote in 2007, I don't know if I've cited it here or not, but if you all would like to see it, I'm happy to share it with you. But it's called, and by the way, the title of the article that I wrote in 2007 is called Taming Global Village Risk. So I think the title of the article kind of speaks for what I was trying to get at in that article. In any event, we've continued that dialogue, we've continued that research. And here we've said that financial models need to be more like models of hurricanes. So models of hurricanes, we don't predict necessarily where the hurricane is going. We predict, we try to understand the intensity of it. We try to understand the magnitude of it, and we tell people to get out of the way. So we need models more like that in capital markets. So we need to capture, and in financial market terms, rather than hurricanes, we just say we need to capture shifts in risk and return globally across an array of asset classes. Just kind of a fancy way of saying we need more flexibility in our modeling. So what I want to do now is talk about, I've been talking to you about things that we do wrong, and I have one more example of things we do wrong, but I do want to give you some hands-on, some things that you can actually take away with you to improve portfolio construction, to improve your portfolio management and your thinking about investments. And the first is actually something that we need to dispense with, something we need to get rid of. And that is the idea of using normal or Gaussian models to describe capital markets. we financial economists have used normal and Gaussian models for many years, not because, by the way, we thought that they were the right way to describe financial markets, but because the technology that was available to us really only allowed us to use normal or Gaussian distribution. But now the technology is advanced, and there really is no reason to use normal or Gaussian models. And so the reason that you shouldn't use normal Gaussian models is right here. So this is a history. You all have probably, I'm sure you've studied statistics, and so you've seen something like this, which is a histogram. The histogram plots the number of occurrences of a particular observation over time. So, for instance, capital markets, the purple here is the actual experience of capital markets. And so capital markets have experienced about a 1 to 2% return, roughly 207 months since 1926. Okay, so that's how this works. And so this thin line that you see here is the normal curve. And what you can see is that there are lots of purple outside of the normal curve. So what that means is that this type of distribution is not doing a very good job of describing the reality. And so all of this white space that's missing is here, and it's out here and out here. So risk, by the way, is not always negative. It's sometimes positive. Okay, so we should be aware of that as well. So if the normal curve doesn't work, I can't leave you there. I have to say, well, what does work? And so what does work is a family of distributions called log stable. And there are other distributions as well. Students T works reasonably well. But there are other distributions that work reasonably well. And so the point of this is to say that there are other distributions that provide better descriptors of what we actually observe in capital markets. So you can see that here, that there's far fewer observations outside of this thin log stable distribution than before. And here I just blow up the left tail. So this is the normal distribution again, and you see these observations here. I'm sorry, the white space here that's actually out here. And then I don't know if you can see this or not, but this log stable distribution has a much fatter tail. So let me put this in more readily identifiable terms. So when I was putting all this together, I asked the question of, in a normal distribution, how many observations would occur from three standard deviations? So this is 2 standard deviations, this is 3 standard deviations, and everything to the left of this is so-called 3 standard deviation events. We've heard about this, right? So how many observations would we expect in a normal distribution to occur in a 3 standard deviation event? Anyone want to venture a guess, by the way? No one wants to guess. It's kind of a difficult question, but the answer is 1.5, so it's between 1 and 2. So a normal distribution would presume 1 or 2 negative 3 standard deviation events over a 100-year period. Anyone want to guess how many we've actually had? You can see it's a lot more than 2. It's 10. Okay? So the number of observations to the left of this, if you add them all up, it's 10. So we've got considerably more left tail events than a normal distribution would anticipate. And so that's a quick, easy demonstration of why the normal distribution isn't very descriptive. And so this tail, it's harder to see, but it does a much better job of doing that, of describing that. There are other ways of doing this as well, and in fact, I'm going to share one with you in just a moment. I've been talking about stocks to this point, but this phenomenon of so-called kurtosis, which is the peakedness, right? So, sorry, I don't know. This so-called peakedness is called kurtosis, and then these observations out here is called skewness, right? Skewness and kurtosis isn't just for equities; it's across all asset classes, as it turns out. If a normal distribution no fat tails would be observations in here. And so you don't see, except for cash, you don't see observations there. Everything is to the right, meaning that all of these asset classes have varying degrees of fat tails. And the worst offender is global high yield, which is just an egregious asset class with negative skewness and very high kurtosis. So that's a very dangerous asset class, by the way, because of those characteristics. So there are other tools and techniques that one can use. I'm not going to go into a great deal of detail. This is an article that I wrote with some, actually my thesis advisor from many years ago, and some colleagues at Virginia Retirement System that we published in the Journal of Portfolio Management that we go through in much detail if you're interested. But what we do is we draw from the insurance literature. And the insurance literature is that called extreme value theory, by the way. And what that literature does is it tries to predict rare events like earthquakes, hurricanes, and tornadoes. Remember the hurricane I showed earlier? So it's called extreme value theory, and we borrowed from that literature to model financial markets. And it tends to work pretty well. Let me show you how this works. So these are graphs of the left tail only, the 5% left tail. And the blue line is the period 1996 to August of 2008. And then the green line is 1996 to December of 2008. So we just add 4 months of history onto that. And I say just because we know that that's fall of 2008, which is a pretty dramatic period. But what you see is the tails are shifting pretty dramatically to the left. Okay, and this is REITs, and then this is global equities, and so everything is shifting to the left. And so what that means is their distributions are not only not normal, they're also dynamic. They also change. So we need models that are dynamic, not just fat, but also allowed to be flexible. We need flexibility in our modeling. And also, not only are returns hard to grapple with, but also correlation. If we've done optimization, I don't know if all of you have done portfolio optimization, but portfolio optimization is about optimizing the level of return per unit of risk. And as part of that optimization, you have to deal with things like how correlated are asset classes. Correlation means if an asset class, if in this case global equities is up 4%, what happens with commodities? This is the commodity index. Well, it turns out that if ACI, if ACWI is up 4%, then you get something around 4% or so for commodities. So in other words, they're positively correlated. Hence, that you get this sort of relationship that looks like this if you were to draw a line. So asset classes tend to be positively correlated, especially in the extremes. So when stocks are down 6%, so are commodities. So that positive correlation creates a difficulty for asset pricing and asset modeling. But it's the reality, right? We should not ignore that. We have to accommodate that because that's how markets work. This is clear evidence of that, and we could do more. So this is a paper that I'm working on with a colleague to sort of take all of this and form an asset allocation strategy out of it. I'm not going to go into much detail here, but basically, let me just give you the high level. What we do is we estimate market risk, and then we forecast risk going forward, and then we take that information and we develop an asset allocation. So let me just ask, if the model or if you think that risk is going to be very high over the next month, what do you do with your asset allocation? You take you put less risk into the portfolio, meaning you give your portfolio more padding, right? So the padding comes from what asset class? Real estate, fixed income, okay, bonds, okay. So our models adapts to the changing dynamics, okay, and that we observe in the marketplace. So let me show you sort of what that looks like. This is our risk. This is our risk indicator. It's pretty volatile. We're working. We have different versions of this. We have another version that's much more smooth. But the point is that the model. It's 0 and 1, so it's either there's the risk. The markets are either in high risk or low risk, and so up here is high risk. This period here, and so the model is. So what I want to show here is it's not to give you all the details behind this, but just to show you that the model does a fairly good job of anticipating risk. And then this is, I don't know if you've seen this sort of graph, but these are the weights of the asset classes through time. So what this means, like in 2008, we know it was a very high risk period, and we said that in a high risk period, we'd want to own more bonds. And so bonds, by the way, this is bonds, investment grade bonds. That's what this stands for. You can see that's this, I don't know, teal kind of color. So in this period in here, you can see the model is purchasing many more bonds. Okay, so it's given the portfolio padding. So that allows the portfolio to, again, adapt to changing risk dynamics in the marketplace. You can also constrain the model so that it doesn't be so crazy.
Sorry,
So-
2 slides before, I think it was very interesting this. So between 2003 and 2007, they go for the risky stuff.
Yeah,
So that's
and
kind
here,
of
this is
shown-
risky stuff. This is equities.
That's right.
That's right.
That's the over-optimism that you said before.
Right. Right. And so this is why the over-optimism. So this is the so-called unconstrained model. In practice, we wouldn't really use an unconstrained model because models aren't, as I said, they're not always reliable. So I just wanted to give a flavor for that. What in practice? The first question I get from our practitioner audience is, okay, well, can you give me something I can use? And the answer is yes. We can run this model through a so-called constrained or bounded optimization. And so here you can see equities are constrained to between like 30 and 40%. Okay, so we're still maximum equities, but we're not 90, 95%. Okay, so this is a way of recognizing that our models aren't perfect, but we want to take advantage of this information to the extent possible. And so this is a way of doing that within some bounds, within some sort of realistic constraints. So that's exactly right. That's exactly what we do here. So you can see more bonds again during this period, just not as much. Okay. And by the way, this is all out of sample. So this is not a back test with perfect information or perfect foresight. This is all a back test where we run the model up to this point and then we forecast. So it's all an ex ante type model for those of you who are interested in that. So I said that standard deviation is not a great measure of risk because it's a normal distribution. What I like to use is a portfolio drawdowns. Back to the example I gave earlier about what's the maximum drawdown or what's the maximum decline in the market. Here we simply relate. I don't know if you all have seen Efficient Frontiers or not, but here we're simply relating the drawdown of the portfolio, which is the maximum decline over the study period, versus the return. So you get this sort of frontier. This is the unconstrained model, this is the constrained model, and then this is our sort of benchmark that we're using to compare ourselves to. So this is good, right? Less drawdown, which means less risk, and then this is good, meaning more return is better. So this is sort of the results of this model. Just again to give you a flavor for how this can be applied or how this can work and may work in practice. And then this is a performance of the back test versus the benchmark. Okay.
What do you think is going to happen next in the financial market?
Yeah, I'm not. I try to stray away from predictions. I spend more time on sort of descriptions. But one thing that we do know from the economics research from Reinhardt and Rogoff and others is that during financial crises that are banking crises, combined with real estate crises, combined with high levels of leverage, these crises take a long time to work through. 10 years is the typical time that these crises take before we're sort of fully through all the impact of that. And that's just an average. So what comes along with that is that long time. By that I mean a long time of much slower growth. Not necessarily negative growth, but slower growth. So in the US, what we've seen in the last 5 years is growth cut in about half. GDP growth cut in about half. So I would expect to see similar for Europe. In fact, the World Bank came out, I got an email alert yesterday that said the World Bank has cut world economic growth by some amount. I forget how much, but what you're seeing is a ratcheting down in expectations for economic growth. And that shouldn't be a surprise to people because that's what we've seen through hundreds of years of studying capital markets and economies, is that these types of crises that developed countries are now experiencing take a while to work through because they're very complicated. Those who are expecting a quick end to this, I'm fearful that they have too high of expectations. It doesn't usually work that way, and it hasn't in the U.S., hasn't in Japan, and it hasn't in other countries that have experienced similar type situations. So that's the one sort of broad prediction I'll make. Capital markets are a little more hard to predict. Hopefully it's just a process of steady improvement. Let's see. Other questions?
Do you think it's just a matter of the financial market crisis, or maybe other things in the economy should change?
Yes. The question is about, is this a financial market crisis or broader? And this particular crisis is broader, and that's what makes it so much complicated, so very complicated. This is what we financial economists would call a systemic event. So the systemic event is something that happens in one, as I define it, something that happens in one part of the economy, say capital markets, or some sector of the capital markets, that then cascades to other parts of the economy and begins to affect other parts of the economy. In this case, we had too much debt, both personal and government debt. We had capital, we had a housing market, prices who had gotten away from the fundamentals. And so all of this cascaded through the financial markets, but it's also cascading through the real economy because housing is something that's very important, of course, to the macroeconomy. And so until that stabilizes, until that market so-called clears, right, until you have growth in the housing market, then we're going to continue to see an economy that's limping along, that's not going to go back, we're not going to be back to that rapid growth that we saw before. And from my conversations, I'm certainly not a global expert on this, I'm not an expert in Spain, but from my conversations with my colleagues at various universities as I've been traveling, they're asking me about the U.S. and I'm asking them about Spain, and we have very similar stories. In other words, this housing market, which is of course very, very weak, is also in Spain. It's also very weak in the U.S. and other parts of the world. And so these things, because housing is such, it's a difficult asset. You can't split it up. You can't sell it very easy. It doesn't trade very easy. It takes a long time to work through these things. And so that's part of what I'm saying is that it takes a long time for the economy to get back on its feet because there was so much excess.